Good morning, Elizabeth.
Good morning, Holmes. And, is it Watson? I want to ask for your help.
Before you ask, let me deduce a few things about you. You are a professor at MIT. You teach a course on social networks. And you are coming to me about the missing degree distribution, correct?
Wow, Sherlock. How did you know all of that about her?
My dear Watson, how often have I said to you that when you have eliminated the impossible, whatever remains, however improbable, must be the truth?
I am not impressed by your skills of deduction. You are in my course. I know the names of all the students in the course.
Now I'm impressed. You know the names of all 50,000 students?
That's why I came to you. Sherlock, you are the best student in the course. The only mistake you have made in the course is not knowing that the Earth is round. Watson, you should enroll as well.
That sounds great. I am going to enroll right away.
Can you give me all the information you have about the missing degree distribution?
I went to the library to read Ramanujan's recently discovered notebook. They found it in King Tut's tomb, near his mother.
It turns out that they are all big fans of social networks. I believe they are also in your course.
Yes, I know. But I typically try to avoid talking to dead people, since they do not reply. Returning to my story, as I was reading the missing notebook, I saw that Ramanujan explained the model of preferential attachment. He says that there are edge events and note events. He briefly introduces the preferential attachment model. He has a truly marvelous demonstration of this proposition which the margin is too narrow to contain. Perhaps Ramanujan will have the space to write it in the next notebook. Ramanujan wrote that the power law of the network goes between 1 to infinity. However, when I did the analysis, I only got the power law from 2 to 3. I want to find the missing degree distribution.
There are two kinds of missing degree distributions, one that goes from 1 to 2, and one that goes from 3 to infinity.
Now I'm impressed. How did you do that so fast?
I read the notebooks as well.
I also would like to know what it means for degree distribution to be in that range. You know that Ramanujan is never wrong. There may be another missing notebook as well. Maybe the proof is there. I want you to help me find the missing degree distribution and the missing notebook.
Your cases have indeed been of the greatest interest to me. Also, I love your course.
I'll make you a deal. If we find the missing degree distribution, we both get a 100 in the course.
I cannot make that deal. That's immoral. But I'll write you a glowing letter of recommendation. We can even write a paper about the missing degree distribution together.
What are you doing, Holmes?
I don't believe this story of the missing notebook. So instead I am writing a notebook to pass off as the missing notebook. This will solve the case. However, I still think we can find the missing degree distribution and the missing notebook.
How? I don't understand. What are you going to write in this notebook?
I can write the proof, and some other conjectures as well. We can develop the theory ourselves. This is very easy. I know how to do it.
You never cease to amaze me. I know you are a talented mathematician, but how can you fake Ramanujan's handwriting?
You forget my talent is a forger. Before completing the notebook, I would like to explain to you my solution for finding the missing degree distribution. First, we must change the model of preferential attachment, and allow the probability of edge attachment and vertex attachment to vary over time.
As Elizabeth mentioned, we need to understand what it means for the degree distribution to be between 1 and 2.
In this case, it's very easy. The number of edges is no longer linear, and therefore p should go to 0. That's why I said that p should vary with time.
What is the meaning of a degree distribution between 3 to infinity?
The meaning is that the network is not connected. Therefore, we should get a new event which Elizabeth is not aware of. This is the event of the arrival of new components.
I enrolled in Elizabeth's course, and I don't like the current analysis of the degree sequence. It's only true for small degrees, and we are interested in large degrees.
I agree with you. I suggest that we improve the analysis of the degree sequence by using martingales. By doing that, we can push the analysis of the high-degree nodes up to a polynomial degree instead of a fixed degree?
How do you know that the new model is the same as the old preferential attachment?
This is an excellent question. The formula of the new model is an extension of the old model. When restricted to the parameters of the old model, it's exactly the same. This is why this is the correct extension.
That's amazing.
Cut out the poetry. Watson, let's go celebrate. Want to know more? Read Sherlock Holmes in the case of the missing degree distribution, as described in Improved Degree Bounds and Full Spectrum Power Laws in Preferential Attachment Networks.